Hi everyone, today we are taking water sample at Basic Section 7 Shah Alam.
Accurate water quality assessment and effective turbidity reduction are essential for ensuring safe and clean water. This experiment used the water quality index WQI concept and the jar test to determine the optimal coagulant dosage for removing suspended particles. 4 tests were conducted: the jar test, pH test, turbidity test, and color test. By optimizing turbidity, pH, and coagulant dosage, the experiment demonstrates how effective chemical treatment improves water quality and supports safe water purification.
Firstly, pour 1000 ml of water sample into each beaker. Preliminary, fill the syringe with the different quantity of aluminium sulfate, such as 0, 2 ml, 4 ml, 6 ml, 8 ml, and 10 ml. For a rapid mixing, agitate the velocity at 140 rpm for 3 minutes. Add the proper quantity of aluminium sulfate solution. Reduce the agitation speed at 70 rpm for 5 minutes. Completing the 5 minutes of stirring, the sample are kept in quiet for sedimentation. Meanwhile, observe the flow settling velocity for 30 minutes.
For the procedures, measure 10 ml of water sample using pipette. The water sample is poured into the sample cell carefully, making sure there are no air bubbles inside. Then, the sample cell was wiped using clean cloth to remove any fingerprints. Next, switch on the turbidity meter, and the sample cell was placed into turbidity meter once it is clean. Then, take the reading of turbidity meter and repeat the same step for the rest of sample cell. This graph shows our jar test result plotting final turbidity against alum dosage. At 0 ml alum, turbidity stay high at 16.1 NTU because particles can settle on their own. Meanwhile, at 4 ml alum, turbidity drops to its lowest point of 0.67 NTU. The alum neutralizes particle charges, allowing them to clump together and settle out effectively. Next, from 6 to 8 ml, turbidity creeps back up slightly due to charge reversal or overdosing. At 10 ml, it drops again due to sweep fluctuation. The conclusion is 4 ml is our optimal alum dosage, which is give us the clearest water using the least amount of chemical. Based on result and analysis, without alum, turbidity only dropped to 16.1 NTU because collider particles naturally repel each other. Adding 4 ml of alum achieved our best result, bringing turbidity down to a minimum of 0.67 NTU through charge neutralization. Increasing the dosage to 6 and 8 ml caused turbidity to rise again due to overdosing and particle restabilization. Therefore, 4 ml is our optimal dosage. It provides the highest water clarity while saving chemical costs and reducing sludge output.
Moving on to the pH test procedure. First, the apparatus used for this test are a pH meter, distilled water, and 6 beakers with water samples. Now, we proceed to the experimental procedure. Step 1. The pH probe was rinsed with distilled water to remove any contaminants prior to measurement. Step 2. The pH meter was switched on and the probe was carefully immersed into the beaker containing the raw water sample to measure the initial pH before the jar test. It was ensured that the sensing tip was fully submerged. Step 3. The pH reading was allowed to stabilize until a steady value was displayed and an indicator sound was heard. Step 4. The initial pH value was recorded in the table as the baseline for all beakers. Step 5. Once the jar test was completed and the samples had settled, Step 1 to 3 were repeated for all 6 beakers to measure and record the final pH after the jar test. Step 6. After completing all measurements, the probe was rinsed again with distilled water and the pH meter was switched off. For results and analysis, the raw water from Shah Alam Section 7 Lake Garden had an initial pH of 5.59. This complies with the national standard for drinking water qualities raw water limit of 5.5 to 9.0. During the jar test, beaker 1 with 0 ml alum physically rose to 5.98 due to carbon dioxide trapping. However, increasing the alum dosage up to 10 mm chemically dropped the final pH to 5.48 due to alum hydrolysis. This final pH violates the mandatory drinking water standard of 6.5 to 9.0, which will cause severe pipe corrosion. Therefore, a full-scale plant treating this lake water must add post-treatment lime to safely restore the pH.
First of all, prepare blank sample by measure 10 ml of distilled water using measuring cylinder and fill the sample cell at 45 degrees to avoid bubbles. Next, measure 10 ml of 6 beaker of water sample, then fill sample cell at 45 degrees to avoid bubble and level it. The measuring cylinder must be rinsed with distilled water every time measuring different water sample. Repeat step 2 to 3 using second beaker of water sample until 6 beaker of water sample. Then the outside surface of sample cell was wiped with clean cloth to remove fingerprint, dust or water droplets that could interfere with the reading. The instrument was then calibrated using distilled water as blank reference to remove interference and set 0 as 0 baseline. The sample cell was placed into spectrophotometer and the color reading was recorded in standard color unit. Based on the color test result, the initial color of all sample was 371 platinum cobalt. As the alum dosage is increased, the final color decreased significantly, showing that alum effectively removed color from the water through coagulation and flocculation process. Without alum, the removal efficiency was only 51.21%. The highest color removal was achieved at 10 ml of alum with 98.11% efficiency and a final color of 7 platinum cobalt. However, 6 ml can be considered the optimum dosage because it achieved 97.84% removal with almost the same performance while using less chemical, making the treatment more economical and efficient.
This project supports Sustainable Development Goal 6, which promote clean water and sanitation. It also supports SDG 40 by reducing pollutant entering aquatic ecosystem. In addition, this project incorporates IR 4.0 technology through the use of digital laboratory instrument, Microsoft Excel for data analysis, and editing software, which is CapCut.
In conclusion, conclusion, this experiment successfully achieved all of its objectives. The jar test showed that aluminum sulfate, or alum, effectively improved the raw water quality by significantly reducing turbidity from 93.8 to 0.67 NTU and color from 301 to 27 pt/CO, while maintaining a stable pH. Based on the results, the optimum alum dosage was 4 mm, providing the best overall treatment performance. These findings demonstrate that coagulation is an effective process for producing cleaner water before further treatment. Overall, this study supports Sustainable Development Goal 6, promoting safe, clean, and sustainable water resources for the community.